The National Electrical Code, specifically NEC 2020 Article 100, provides a definition for structural ceiling. This definition is crucial in determining whether certain elements are considered to be within the dedicated electrical space above an electrical panel. According to the NEC, a structural ceiling is a ceiling to which luminaires, equipment, conduit, or cables are attached, and that serves to support a floor or roof or an overhead system. The key aspect of this definition lies in the attachment of electrical or structural components to the ceiling and its role in supporting a load-bearing structure. Now, let's consider a scenario where water piping is run above an electrical panel, and a hard gypsum fire-rated ceiling is installed below the piping at a height of 7 feet. The piping remains within the 6 feet of dedicated electrical space above the panel, but above the newly installed ceiling. To determine whether this piping is within the dedicated electrical space, we must apply the NEC definition of a structural ceiling. If the water piping is not attached to the gypsum ceiling, the ceiling does not qualify as a structural ceiling in relation to that piping. Consequently, the piping would not be considered to be within a dedicated electrical space above the panel as defined by the NEC concerning structural ceilings. The dedicated electrical space above an electrical panel is intended to provide clear access for electrical work and to protect the electrical equipment from foreign objects or systems that could pose a hazard. The NEC specifies that this space should be dedicated solely to electrical installations. If the water piping were attached to the ceiling, making it a structural component supporting the piping, it could then be argued that the piping is within the dedicated electrical space, which would likely violate the code. However, since the piping is simply located above the ceiling and is not attached to it, the NEC definition is not triggered in this manner. It is essential to distinguish between a standard ceiling and a structural ceiling in this context. A standard ceiling, such as a suspended or dropped ceiling, typically does not support any significant loads and is primarily used for aesthetic or acoustic purposes. In contrast, a structural ceiling is an integral part of the building structure and supports various elements, including electrical equipment or other systems. The NEC definition focuses on ceilings that perform this structural function. When evaluating compliance with the NEC, it is crucial to consider the specific language of the code and how it applies to the particular installation. In the case of the water piping above the electrical panel, the absence of attachment to the gypsum ceiling is a critical factor in determining whether the piping is within a dedicated electrical space. If there is any doubt or ambiguity, it is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. They can provide expert guidance based on the specific details of the installation and help avoid potential violations or safety hazards. It is also important to note that the NEC is updated regularly, so it is essential to stay current with the latest edition to ensure that all installations comply with the most recent requirements. The NEC is a comprehensive document, and understanding its various articles and definitions is crucial for anyone involved in electrical work. Now, let's discuss some additional considerations related to dedicated electrical space and the NEC. The NEC specifies the dimensions of the dedicated electrical space, both above and below electrical equipment, to provide adequate clearance for working on the equipment and to prevent obstruction by other systems. The height of the dedicated space above an electrical panel is typically 6 feet, or the height of the equipment, whichever is greater. This space must be kept clear of any foreign systems such as piping, ductwork, or structural elements that could interfere with electrical work. The width of the dedicated space is typically the width of the equipment plus 30 inches on each side, providing a total of 60 inches of clear space. The depth of the dedicated space is typically 36 inches, measured from the front of the equipment. These dimensions are intended to provide adequate working space for electricians and other qualified personnel to safely install, maintain, and repair electrical equipment. In addition to the dedicated electrical space, the NEC also requires clear access to electrical equipment. This means that there must be a clear path to the equipment, free of obstructions, that allows personnel to reach the equipment without difficulty. The access path must be wide enough and high enough to accommodate personnel carrying tools and equipment. The NEC also specifies the minimum headroom required in working spaces around electrical equipment. The minimum headroom is typically 6 feet 6 inches, measured from the floor or platform to the lowest obstruction above. This headroom requirement is intended to prevent personnel from bumping their heads on overhead obstructions while working on the equipment. When installing electrical equipment, it is essential to carefully consider the location of the equipment and the surrounding environment to ensure that the dedicated electrical space, access path, and headroom requirements are met. Failure to comply with these requirements can result in code violations, safety hazards, and difficulties in maintaining and repairing the equipment. In the context of the water piping above the electrical panel, it is crucial to ensure that the piping does not obstruct the dedicated electrical space or the access path to the panel. If the piping is located within the dedicated space or obstructs access to the panel, it must be relocated or protected to comply with the NEC requirements. One common method of protecting electrical equipment from foreign systems is to install a physical barrier, such as a shield or enclosure, around the equipment. This barrier can prevent water or other fluids from dripping onto the equipment and can also protect the equipment from physical damage. However, the barrier must be installed in a manner that does not obstruct the dedicated electrical space or the access path to the equipment. Another important consideration is the potential for water leaks or condensation from the piping. If there is a risk of water leaking or condensing on the electrical equipment, measures must be taken to prevent this from happening. This may involve insulating the piping, installing a drip pan, or providing adequate ventilation to prevent condensation. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations. It is essential to check with the local authorities to ensure that all installations comply with all applicable codes and regulations. The NEC is a minimum standard, and local codes may impose more stringent requirements in some cases. For example, some local codes may require additional clearance around electrical equipment or may restrict the types of materials that can be used in electrical installations. When in doubt, it is always best to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. They can provide expert guidance based on the specific details of the installation and help avoid potential violations or safety hazards. Maintaining a safe and code-compliant electrical installation is crucial for protecting people and property from electrical hazards. By understanding the NEC requirements and following best practices, you can help ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and regulations. In summary, the NEC definition of a structural ceiling is critical in determining whether elements such as water piping are within the dedicated electrical space above an electrical panel. The absence of attachment to the ceiling is a key factor in determining whether the ceiling is considered structural in this context. Always consult with qualified professionals and stay updated with the latest NEC edition to ensure compliance and safety. Let's delve into some hypothetical scenarios to further illustrate the application of the NEC definition of structural ceiling. Scenario 1 involves a large commercial building where several electrical panels are installed in a utility room. Above these panels, various HVAC ducts and cable trays are suspended from the main structural beams of the building. In this case, the main structural beams, being part of the building's primary support system, clearly qualify as a structural ceiling. If the HVAC ducts or cable trays are directly attached to these beams, they would be considered within the dedicated electrical space above the panels, potentially violating NEC regulations unless proper clearances and protections are in place. Scenario 2 presents a residential setting where an electrical panel is located in the basement. The homeowner decides to install a drop ceiling to improve the aesthetics of the space. The drop ceiling is suspended from the floor joists above using thin wires. In this scenario, the drop ceiling itself is not considered a structural ceiling because it does not support any significant load and is not directly attached to the building's primary structure. Therefore, any items located above the drop ceiling would not automatically be considered within the dedicated electrical space above the panel simply by virtue of their proximity to the drop ceiling. However, it's still crucial to maintain proper clearances and ensure that these items do not obstruct access to the electrical panel or pose a safety hazard. Scenario 3 involves a manufacturing facility where heavy machinery is supported by a network of steel beams. Electrical conduit and wiring are run along these beams to power the machinery. In this case, the steel beams are undoubtedly a structural ceiling as they are integral to the building support system and directly support heavy equipment. The electrical conduit and wiring attached to these beams would be considered within the dedicated electrical space above any electrical panels located nearby, and compliance with NEC regulations regarding clearances and protection would be essential. These scenarios highlight the importance of understanding the specific context and construction details when applying the NEC definition of structural ceiling. It's not simply about the presence of a ceiling, it's about its structural function and its relationship to other elements in the building. Let's further elaborate on the concept of dedicated electrical space and its significance for safety and maintainability. A dedicated electrical space, as defined by the NEC, serves several critical purposes. Firstly, it provides a safe working environment for electricians and other qualified personnel to install, maintain, and repair electrical equipment. The clear space allows for easy access to the equipment and reduces the risk of accidental contact with live parts. Secondly, it prevents the obstruction of electrical equipment by foreign systems such as piping, ductwork, or structural elements. Obstructions can make it difficult to access the equipment and can also create a fire hazard. Thirdly, it ensures that the electrical equipment is properly ventilated and does not overheat. Overheating can damage the equipment and can also create a fire hazard. The NEC specifies the dimensions of the dedicated electrical space based on the size and type of equipment. The height of the dedicated space above an electrical panel is typically 6 feet, or the height of the equipment, whichever is greater. The width of the dedicated space is typically the width of the equipment plus 30 inches on each side. The depth of the dedicated space is typically 36 inches, measured from the front of the equipment. These dimensions are intended to provide adequate working space and to prevent obstructions. In addition to the dedicated electrical space, the NEC also requires clear access to electrical equipment. This means that there must be a clear path to the equipment free of obstructions that allows personnel to reach the equipment without difficulty. The access path must be wide enough and high enough to accommodate personnel carrying tools and equipment. The NEC also specifies the minimum headroom required in working spaces around electrical equipment. The minimum headroom is typically 6 feet 6 inches, measured from the floor or platform to the lowest obstruction above. This headroom requirement is intended to prevent personnel from bumping their heads on overhead obstructions while working on the equipment. When installing electrical equipment, it is essential to carefully consider the location of the equipment and the surrounding environment to ensure that the dedicated electrical space, access path, and headroom requirements are met. Failure to comply with these requirements can result in code violations, safety hazards, and difficulties in maintaining and repairing the equipment. Let's consider some practical examples of how the dedicated electrical space requirements can impact electrical installations. In a commercial building, an electrical panel is installed in a mechanical room. The room also contains HVAC equipment, plumbing pipes, and ductwork. To comply with the NEC, the electrical panel must have a dedicated electrical space that is free of obstructions. This may require relocating some of the HVAC equipment or plumbing pipes to create the required clear space. In a residential setting, an electrical panel is installed in a basement. The homeowner decides to build a storage shelf above the panel. To comply with the NEC, the storage shelf must not obstruct the dedicated electrical space above the panel. This may require installing the shelf higher up or moving the panel to a different location. In an industrial facility, an electrical panel is installed near a conveyor belt. To comply with the NEC, the conveyor belt must not obstruct the dedicated electrical space or the access path to the panel. This may require relocating the conveyor belt or installing a barrier to protect the panel from damage. These examples illustrate the importance of carefully planning electrical installations to ensure compliance with the dedicated electrical space requirements. By following the NEC guidelines, you can create a safer and more maintainable electrical system. Let's now discuss the implications of the NEC definition of structural sealing for various types of electrical installations. Firstly, in the context of lighting systems, if luminaires are directly attached to a ceiling that supports a floor or roof, that ceiling is considered a structural ceiling. This has implications for the wiring methods used to supply power to the luminaires, as the NEC has specific requirements for wiring in or above structural ceilings. Secondly, for conduit and cable installations, if conduit or cables are attached to a ceiling that supports a floor or roof, that ceiling is considered a structural ceiling. This affects the support requirements for the conduit and cables, as they must be adequately supported to the structural ceiling. Thirdly, when it comes to equipment installations, if electrical equipment, such as transformers or panel boards, is attached to a ceiling that supports a floor or roof, that ceiling is considered a structural ceiling. This has implications for the mounting and support of the equipment, as it must be securely attached to the structural ceiling to prevent it from falling or shifting. In each of these cases, the NEC definition of structural ceiling plays a crucial role in determining the applicable requirements for the electrical installation. It is essential to carefully consider the structural function of the ceiling and its relationship to the electrical components when designing and installing electrical systems. In addition to the specific requirements for wiring, support, and mounting, the NEC also has general requirements for electrical installations in or above structural ceilings. These requirements address issues such as access, ventilation, and protection from physical damage. Access to electrical equipment in or above structural ceilings must be readily accessible for maintenance and repair. This may require providing access panels or doors in the ceiling. Ventilation must be adequate to prevent overheating of electrical equipment in or above structural ceilings. This may require installing ventilation fans or louvers. Protection from physical damage must be provided for electrical wiring and equipment in or above structural ceilings. This may require using conduit or other protective measures. By following these general requirements, you can ensure that electrical installations in or above structural ceilings are safe, reliable, and compliant with the NEC. Let's shift our focus to the process of determining whether a ceiling is considered structural according to the NEC. This determination often requires a careful assessment of the ceiling's construction, function, and relationship to other building components. Firstly, consider the construction of the ceiling. Is it made of materials that are capable of supporting significant loads such as concrete, steel, or wood? Or is it made of lighter materials such as gypsum board or suspended ceiling tiles? Secondly, examine the function of the ceiling. Does it support a floor or roof above? Or does it simply serve as a finished surface? Thirdly, evaluate the relationship of the ceiling to other building components. Is it directly attached to the building's structural frame? Or is it suspended from the frame by wires or other means? By answering these questions, you can gain a better understanding of whether a ceiling is considered structural according to the NEC. If the ceiling is made of load-bearing materials, supports a floor or roof, and is directly attached to the building's structural frame, it is likely to be considered structural. On the other hand, if the ceiling is made of lighter materials, does not support a floor or roof, and is suspended from the frame, it is less likely to be considered structural. However, it is important to note that the final determination of whether a ceiling is structural must be made by a qualified electrical inspector or engineer. They will take into account all of the relevant factors and apply their professional judgment to make a determination that is consistent with the NEC and other applicable codes and regulations. Let's delve into the importance of documentation and communication when dealing with the NEC definition of structural ceiling. Proper documentation of electrical installations is essential for ensuring compliance with the NEC and for facilitating future maintenance and repairs. Documentation should include drawings, specifications, and other relevant information about the electrical system. The drawing should show the location of all electrical equipment, wiring, and conduit. The specifications should describe the materials and methods used in the installation. Other relevant information may include load calculations, voltage drop calculations, and coordination studies. Documentation should be kept up to date and readily available for reference. This will help to ensure that future work on the electrical system is performed safely and correctly. Communication is also crucial for ensuring compliance with the NEC. All parties involved in the electrical installation, including the owner, architect, engineer, contractor, and inspector, should communicate effectively with each other. This will help to ensure that everyone is on the same page and that the installation meets all applicable requirements. Communication should be clear, concise, and timely. Any questions or concerns should be addressed promptly. Regular meetings and site visits can help to facilitate communication and ensure that the installation is progressing smoothly. By emphasizing documentation and communication, you can help to create a collaborative environment that promotes safety, compliance, and quality in electrical installations. Let's explore some of the common misconceptions surrounding the NEC definition of structural ceiling. One common misconception is that any ceiling that is not suspended is considered structural. This is not necessarily true. A ceiling may be directly attached to the building's frame without being considered structural if it does not support a floor or roof. Another common misconception is that any ceiling that supports lighting fixtures is considered structural. Again, this is not necessarily true. A ceiling may support lighting fixtures without being considered structural if it does not support a floor or roof. The key factor in determining whether a ceiling is structural is its ability to support a floor or roof. If the ceiling does not support a floor or roof, it is not considered structural, regardless of how it is constructed or what it supports. It is important to dispel these misconceptions to ensure that electrical installations are designed and installed correctly. By understanding the true meaning of the NEC definition of structural ceiling, you can avoid potential code violations and safety hazards. Remember, the NEC is a complex and ever-evolving document. It is essential to stay up to date with the latest changes and interpretations to ensure that your electrical installations are safe, compliant, and reliable. And always consult with qualified professionals when in doubt.